Hey guys, so we're welcome to the 2019 paper, and we are on 2019 paper. We're starting off with a bit of probability. Okay, there are 85 students in third year English school. 2/5 of them, which means 2 out of every 5 students, do business studies. Work out the number of students that do not do business studies. Well, we can do it two ways. We can multiply 2/5 by 85, and when you multiply 2/5 by 85, what we should get is 34. And then you would say, well, look, there's 34 students that do business studies, so 85 take away 34. That should lead to your 51. Another way of doing it would be to multiply 85 by 3/5, because if 2 and 5 students don't do business studies, that means 3 and 5 students do, and then you get 51 that way as well. Okay, 26 of the students in third year do art. Okay. So work out the percentage of students in third year who do art to correct to one decimal place. Well, that's going to be 26 students out of the total of 85, and then you're going to multiply that by 100. When you put that into your calculator, you should get 30.588, and then we all know that rounds off to 30.6% to one decimal place. Okay, let's keep moving. Now we're on to part C. The ratio of students to teachers in Liam School is 15 to 1. Okay, the school hired one extra teacher. So the whole thing means 15 students to one teacher. Okay, so the population of students is 15 times that of the teacher. While the number of students stayed the same, the new ratio of students to teachers was A to 1. Where A is an element of Q. A element of Q means A is a fraction. Okay. Put a tick in the correct box to show which statement is true. Tick one box only. Give an example to show your answer. Well, here's what I do. Imagine there's 150 students in the school, and then imagine there's 10 teachers. Okay. In a scenario like this, then what we can say is that there's when we hire the extra teacher, okay? So see the way we hired the one extra teacher. So that means 11 teachers and then still 150 students, okay? So what we're going to look at here is that what's the new ratio of 150 is to 11. So we're going to divide both sides by 11. So 150 divided by 11. We'll just quickly put in sort of decimal case, 13.63. So we can see that the 13.63 is to 1. When we divide both sides by 11, we can see that the A value has to be below 15. Okay? Alright guys, let's keep moving on. Right, write down the first 4 factors of 45 apart from 1 and 45. Well, the factors of 45 are 1, 3 divides into 45, 5 divides into 45, 9 divides into 45, and 15 divides into 45, and 45 divides into 45. So what's it? 3, 5, 9, and 15. Okay. N is a whole number bigger than 1. It just has 2 factors, 1 and n. Pick a tick in the correct box to show what is negative in this type of number. The answer is prime number, lads. Please remember, prime numbers start at 2. 2 can only be made using 2 multiplied by 1. 3 can only be made using 3 multiplied by 1. 4 is not a prime factor because you can make it using 2 multiplied by 2 and 4 multiplied by 1. The fact that it only has 2 factors means it's got to be prime. Okay, P is a whole number. Apart from 1 and P, the only other factor P has is 7. Work out the value of P. Okay. Apart from 1, only other factor it has is 7. So let's count up in the sevens. 7 only has a factor of 1 and 7. Okay. Apart from 1 and P, only other factor P has is 7. So it has 3 factors basically. If we use 14, P is a whole number. Work out the value of P. Okay. So it needs 3 factors, okay? So 7's ruled out because it only has 2 factors. 14 is ruled out because it has 1, 2, 7, and 14. We're going to keep working our way up here. 21 has 1, 3, 7, and 14. That's still 3 of them. 28 has 1, 2, 4, 7, 14 and 28. That's too many factors. I think we might be looking at 49 here, guys, not 35 but 49. I'm going to go straight to 49 and try and work this out. 1, 7 and 49. The answer's got to be 49 because 1 and P, 1 is 1, P must be 49 because it has itself and the number 1 and only then the number 7. That's 3 factors in total. 1, 7 and P is the list we're looking for, and this is 1, 7 and 49. So the answer is 49. Okay, so that's sort of a bit of just mentally working it out. Okay, next one. Write down 4 factors of 2k plus 8 apart from 1 and 12k plus 8. Well, with 12k plus 8, a factor is anything that will divide into it. So technically 2 is a factor because when I divide it by 2, it's 2 and 6k plus 4. So 2 could be a factor, and obviously 6k plus 4 is a factor because when you multiply them together you get the original term. In the same way, factors of 8 are 2 and 4 and 1 and 8 because when you multiply them together you get 8. We could also divide this by 4. So factorize 12k, we're taking out 4 and we get 3k plus 2. So that could be our other one. 3k plus 2 and 4. So there's your 4 factors right there. Okay, let's move on. The distance between Earth and Mars is at least 56,000 kilometers. Write this distance in the form scientific notation. Well, there's 2 ways of doing this, guys. The first way is to keep dividing the number you're given by 10 and count how many times you need to divide it by 10. So 56, 1, 2, 3, 4, 5, 6. Keep dividing by 10 until you get a number between 1 and 10. That's once, that's twice, 3 times, 4 times, 5 times, 6 times, 7 times. So it's the same thing as 5.6 by 10 to the power of 7. Okay, so what we might try here, guys, is we might try scientific notation this time. So you go to mode, setup, and you can go to science mode, and you go to 0, and you just put in your 56,000 this way, with the 56 million, I believe, and then put it into that, and you get 5.6 by 10 to the power 7. Okay, whatever suits you. Okay, the diameter of a human hair is roughly this much centimeters. Write this diameter in the form of b to the power of 10n. Okay, once again, your scientific calculator can do this for you. 0.0075. Okay, and it says 7.5 by 10 to the power of minus 3. Another way of doing it would be to get your 0.0075 and keep multiplying it by 10 until it makes a number between 1 and 10. So this would be once, this would be twice, this would be twice, and this would be 3 times. So you can see here that by multiplying it out by 10 3 times, you turn it in between a number between 1 and 10. So this means your answer will be 7.5 by 10 to the power minus 3. Nextly, Lewis was driving 90 kilometers per hour when he sneezed. During the sneeze, his eyes were closed for half a second. Work out how many meters he traveled in this time. How many meters he traveled in this time? Well, that's interesting. So here's what we're going to do. 90 kilometers is going to need to change to 90 kilometers per hour. We're going to have to change that into meters per second, and then we're going to have to multiply by half a second. So 90 kilometers per hour is 90 kilometers is 90 multiplied by 1,000, which would make it 90,000 meters. And in 1 hour is in 300. So 1 hour. Well, sorry, 90,000 meters in 1 hour. Now we got to change 1 hour to seconds, and so in 1 hour you have 60 minutes, and in every 60 minutes you have 60 seconds. So 60 by 60 is 3,600 seconds. So essentially you did 90,000 meters in 3,600 seconds. Okay, divide both sides by 3,600. So you're going to divide your 90,000 by 3,600. And once again, I'm just going to shift back our setup. I don't want to be in science mode, so you need to go to mode actually. Mode, sorry, shift, setup, normal, and go back to normal 1. Okay. And what we're going to do here is we're going to divide our 90,000 by 3,600. And this means we move 25 meters in a second. So this means 25 meters in 1 second. So in a half a second, we divide both sides by 2. This means we must have traveled 12.5 meters in 0.5 of a second. Okay with you guys? Alright, let's keep moving. Okay. Katie has a gross income of 52,460. 8.5% of this is deducted in pension contributions. The amount left is Katie's taxable income. Work out Katie's taxable income. Okay, so there's 2 ways of doing this. The first way is to multiply your 52,460 by 8.5%. And when you multiply by 8.5% in your calculator, you will get €4,559.10. Now what you can do next is you take that away from your 52,460, and what you should get in your answer is 48,090 cents. Okay, so there you go there. Alternatively, you could multiply by 52,460 by 91.5%, and that automatically takes away the 8.5% and gives you the same answer. Okay, Katie pays income on her taxable. Katie pays income on her taxable income at a rate of 20% on the first 34,000 and 40% on the balance. She has annual tax credits of 4,200. Work out Katie's net income after tax has been deducted. Well, the way I would have taught you guys in school would have been you have your gross income, then you have your tax at, well in this case it's 20%, then you have your tax at 40%, then you add them together to get your gross tax. And then your gross tax, you take away the tax credits, because basically gross tax is how much tax you're meant to pay, and then you don't have to pay all of it if you have tax credits. And then you have what's called tax payable, and this is how much you actually take away from your, or net tax, basically how much you take away from your gross income, and then you have net pay. Now before we do that, we have our 48,090. Okay, let's give me a sec. So we have our 48,000.90, like so. And what we're going to do is start off by we have to divide this money up into 2 parts. The first part is on the first 34,000, which is up here. And then the second part is going to be the remaining. When you take 48,090, take away 34,000, there's going to be the remaining 14,090 cents. Now the 34,000 gets multiplied by 20%, and the 14,090 cents gets multiplied by 40%. And what we see here is both answers are going to be, so step 1 will get you 6,800 when you multiply the 2 of them by each other, and then the second one will get you 5,600.36. Okay, and then when you add both of them together, what you're going to get is your gross tax. So you're going to add the 2 of these together, and what you should get is 12,436. And then we got to take away our tax credits, which is minus your 4,200 from this. So it's the gross tax, take away the tax credits, and what that will leave us with is tax payable, which is 8,236. Next, we're going to take this number away from your gross income at the top, and we'll take both of them away from each other. We get an answer of 39,800.54. Okay, now let's move on. Katie got a credit card bill 3 months ago for €420. The interest rate on her credit card is 2% per month, compounded monthly. She's not paid off her bill. Work out what her bill is now, give her answer in euro, correct in euro cent. Okay, so what happens every month is that it basically gets increased by 2% each month. So you can do 420. And what you can do is you can multiply it by 102%. Okay, or you can multiply it by 1.02 each time. So you have to do it 3 times, okay? So 420 multiplied by 1.02 or 102%. There's once. Okay, so that'd be 428.4. There's twice. Oh, sorry, 0.2. That's an extra 2% on, so 436.968. Okay, and then multiply it one more time by 1.02, and your third answer would be 445.71. Now you can multiply 3 times and get this answer this way. The quickest way to do it, however, is to write down 420 multiplied by 1.03. I'll say 1.02, excuse me, because it's 2% extra, and do that to the power of 3. And you'll find it's the same thing as increasing it by 3% 3 times anyway. So 1.03 to the power of, I'll say 1.02, twice I did that, to the power of 3. And you find that your answer is 445.71. Okay, when you round it off. 445.71. Okay, done. C. Katie bought her motorbike last year. When she bought it, the motorbike lost 10% of its value. The value of the motorbike is now 12,150. Work out the value of the motorbike when Katie bought it. Well, when she bought it, it was worth 100%. It lost 10%, so it's currently worth 90% of what it used to be worth, which is 12,150. So to figure out what 1% is, you just need to divide by 90. Figure out what 1% is, so 12150 divided by 90. 1% would be 135. Okay. And then multiply both sides by 100 to find out what 100% is. And we figured out that her bike was worth 13,500 was the selling price. Or sorry, the price of the motorbike when she bought it. Okay. Next thing. A is a set of multiples of 2, B is a set of multiples of 3, and C is a multiple set of 4. Write down a number that is in A, B, and C. Well, A is 2, 4, 6. It keeps going on forever because it doesn't really limit us in what we need to write. And then this one is 9, 12, 15, 18. Then 4, 8, 12. So a number that's in all 3 sets, this means intersection, which means in all 3 sets will be 12. There's other answers as well, but 12 will probably be the first answer that's on the list. Okay, let's go to question B. Explain why C is a subset of A. So what a subset means is that any numbers in one set are contained within the other set. So for example, if I had 2 sets X and Y, every number in Y would also be contained in X. So if I said X was 1, 2, 3, and 4, and then I said Y was the numbers 1 and 2, you can see that everything in Y fits into X. So Y would contain 1 and 2, but X would then contain 3 and 4 on the outside. So x contains all the numbers in its boundaries. In fact, if I was just to rub out y as an example, that's what x looks like on its own. X is this shape, and it contains 1, 2, 3, and 4, and y basically is inside of x as this little panel here. So we have to explain why C is a subset of A. Well, we can see that every multiple of 4 is also a multiple of 2. If you take 4, 8, and 12, you can see they're also inside of A as well. So everything that's going to be, everything that A has is also going to be inside of C. So I think the answer what we're looking for here is that every multiple of 4 is also a multiple of 2. All multiples of 4, so we'll just, I think we'll type this out, okay? All multiples of 4 are even, so therefore are also multiples of 2. Okay, there we go. Happy days. Move on. Here are the 3 sets, and there are 7 regions in the Venn diagram. Now, 7 regions in the Venn diagram basically means region 1, region 2, region 3, region 4, region 5, region 6, and region 7. So we can see the 7 different regions as shown. Okay, now what does it want me to do in part B? Okay, because C is a subset of A, there are 2 regions in the Venn diagram that have no elements. Write an X in each of these regions for the Venn diagram above. Okay, so I have to show something that doesn't exist really. Okay, so a multiple of A only would be like the number 2 or the number 10. A multiple of 3 only would be 3 and 9. It doesn't have anything in common with 4 and 2. There's much more of them now. There's tons more, but I'm not going to put them all in. Now, then there'll be other ones like 6, as an example. 6 is actually just a multiple of 2 and 3, but it's not a multiple of 4. The only one that is a multiple of 2, a multiple of 3, and a multiple of 4 we discussed earlier is 12. That is the only one that is a multiple of all 3 of them. Okay? Now, a multiple of 2 and a multiple of 4 could be the number 8. In fact, I can't make any multiple of 4. There's no multiple of 4 that doesn't go in here, because 16 would go in there as well. So this means that this set here is completely blank. C doesn't have any only multiples of 4. Any multiple of 4 is also a multiple of 2. This makes this a blank area. Now, the problem is this area 2 is also going to be blank, because remember, every multiple of 4 is also a multiple of 2. So if you take anything in the list for 3, let's say 3, 6, 9, 12, 4, 8, 12, you won't put it in here because they're also multiples of 2. So they'd move in here, and that would essentially leave this area blank as well. Okay, so that would put that back in there, and this is your second blank area. Okay, so that's that one gone. Okay, next one. Each of the other 5 regions in the Venn diagram has some elements. In each case, these 5 regions above, write one of the elements in that region. Okay, so I only need to write one example of an element in the other region. So I currently have 2 examples, so I'll just get rid of that one, get rid of that one, and get rid of that one. And what this does is basically, and just make sure that's the number 12, and we're sorted. That's the part 3 done. Okay, now on to question 6. Okay, Poppy and Ella ran a 5-kilometer race. The simplified graph shows the time it took Ella to run the D kilometers during the race. One of the points on the graph is marked A. The distance on the horizontal axis, for example, it took 26 minutes for Ella to run the whole 5 kilometers. Okay, so what we're basically getting at here, guys, is that if you look at the graph here, this is the point 526, and 526 means it took 5 kilometers 26 minutes. This point here, point A, would be the point, I believe it to be 8. Yeah, it is 8, so 2-8. This means 2 kilometers in took 8 minutes. Okay, now what we're going to do is look at the next questions here. The table below shows the time it took Poppy and Ella to run each of the distances given. Using the figures, draw a graph of the diagram showing the time it took Poppy to run D kilometers during the race. Okay, so we need to sort out Poppy's time, and we also need to fill out Ella's numbers as well by the looks of it. Okay, so I might just copy and paste this over here into the previous question. So good. Then we'll go down here, like so, and paste. Okay, so Ella, we'll get some of Ella's figures here. Okay, so Ella was 1-4. Ella was then 2-8. I believe she was then she went faster. See the way we can see a slope change? So she was going 4 kilometers per minute. Oh, sorry. She was going not 4 kilometers a minute. That's wrong. She was going, what was it? She started to go faster basically because the slope changed, right? So she's basically, this is every kilometer takes how much minutes is what we're looking at. So 3 kilometers then was at 14 minutes, and then 4 kilometers was at 20. Okay, so what do we have here? We have 3:14, and then we have 4:20. So we can see Ella was going 4 at the start, and then she jumped up to 6s. So she was doing basically 6 minute kilometers. So 4 minute kilometer at the start, then each kilometer took 6 minutes. Okay, so fill in the diagram. So we got there is 1-5, then we got 2-10, then we got 3:17, which is this one here, and then we got so she did 1 kilometer in 5 minutes, the next kilometer in 5 minutes, then the next kilometer in 7 minutes, then she did another kilometer in 7 minutes, and then the last one in 6 minutes. Okay, so let's see what happens here. So we got 4, 10, 17, sorry, 3, 17, 4:24, 4:24 being there. Then we have 5:30. So we can see that the other girl, or Poppy, is in the lead at the moment. Okay, so we're going to do another graph here, like so. Let's get back to this. Standard speed at the start, then she changes angle at the end, like so. Okay, so that's both graphs done, and I filled out the 3 missing values, done, and I also graphed Poppy's race, that's also done. Now, show that Poppy's times in the table do not make a quadratic sequence. Okay, so why do Poppy's times not make a quadratic sequence? Okay, so I'm just going to copy and paste Poppy's times over, if I can. So, okay, so I'm just going to copy and paste this over. So a quadratic sequence is where the second difference is the same. Okay, so the first differences are different, but the second differences are the same. So written up here is the differences in so we go 5, 10, 17, 24 and 30 her times. Okay, and then we have a gap of 5, 7, 7 and 6. We can see the first differences aren't the same, and then we can see that the second differences are also not the same. So therefore this does not qualify for a quadratic. Second differences are not constants, so it's not a quadratic series. Okay. It took Ella 26 minutes to run 5 kilometers. Work out Ella's average speed for the race. Give your answer in kilometers per hour. Well, so distance over time, and basically kilometers per hour. So it's 26 minutes divided by 60. Okay, so distance is 5 kilometers, no bother. And then you can do this two ways. You can either divide it by 0 hours 26 minutes using the DMS button on your calculator, or you can divide it by 5 divided by, you need to put it into hours, and this is 26 of 60 minutes of an hour. So you can do either one of these and they should both yield the same answer. Okay, so 5 divided by 0 hours 26 minutes, and what we get there is 11.54 kilometers an hour. Or if we did the second method, where it's 26 over 60, you still get your 11.54. And I want it in decimal places, okay? 11.54 kilometers per hour. Okie dokes, next question. Tick the correct box to show what happened to Ella's speed after 2 kilometers, which is marked on the graph. Well, we can see the steeper slope happened. So Ella was going this fast, now increased her speed upwards. And as discussed on the graph earlier, you can see that she was doing, oh sorry. Actually, her speed slowed because it's a different graph, it's a different type of graph. Usually it's the slope goes upwards, but what we can see here is that it's taken 6 minutes for a kilometer now, while at the start it took 4 minutes for a kilometer. So essentially what's happened there is that she has gone, she's basically, her speed decreased. Okay, so her speed decreased. Okay, E. That's E done. Now, F. Kieran also ran the 5 kilometer race. He drew the graph below to show the time that it took him to run the race. The part of Kieran's graph marked C is the vertical line. Okay, awesome. What does part C tell you about Kieran's running at this stage of the race? Well, part C tells you that part C says that it's the 0.210. This means after 2 kilometers, he ran, 10 minutes took 2 kilometers. And then we also have the point 215, which means 15 kilometers also took 2 minutes. So this means Kieran stopped running for 5 minutes. Okay? So Kieran stopped running for 5 minutes. Okay. And stop.